Is an old AP question about a bug that travels along a straight line. And it talks about that bug, and the graph was similar to this. It's not exactly this graph, but the graph was very similar to this. And it talks about the bug traveling the straight line. And the question asks for these things right here. All right. Part A. Where is the bug the farthest, fartherest, is that the word? What's the word there? Furthest? Away from the origin and they're going to tell us that at t equals 0 the bug's position is at 0. Okay. B, what is the bug's displacement at t equals 6, and then what is the total distance the bug travels from the interval of 0 to 6, and where does the bug change directions? All right, so we've got those questions to answer. It tells us at time 0 that the bug's displacement is 0. All right, so how do we solve for 0 to 6, and we'll just call this b of t, dt. In just regular people's terms, how would you solve for the antiderivative from 0 to 6 here?
Find the area between 0 and 4 and then subtract it by the area between 4 and 6.
Okay, so basically we can say that it's the integral from 0 to 4 of b of t dt, and then plus the integral from 4 to 6 of b of t dt, because 4 to 6 of b of t dt is going to be a negative value, so it's what was just said. We're going to subtract what the area is because it would have a negative integral there. So what is the area from 0 to 4 of b of t dt? 7, okay. So this portion right here, just the rectangular portion, is going to have an area of 6, and then that's going to have an area of 1, so we get 7 here. Plus, now, again, we get a negative area here. It's 1/2 base times height because it's a triangle. So we get what here for b of t? -2. So the antiderivative of this function is, well, I've already said it's equal to b, is 5. All right, now that would actually be the displacement of the bug. The bug has been displaced 5 units. And because it's positive, it would be 5 units to the right. We do this right, left, positive values mean traveling to the right, negative values mean we're traveling to the left. So we get that for that. Now, that's the total displacement of the bug. Now, where would the bug be farthest from the origin? At 4. What is happening at 4 seconds? The velocity changes from positive to negative. And if velocity changes signs, what does that mean is happening? Yeah, we change directions there. So we're changing signs here, so we're changing directions. So the bug is going to change directions at 4. What is the total distance that the bug travels? Oh, well, what's the answer to part A? Where's the bug the farthest away from the origin?
4.
At time equals 4, right? But where the bug is, if it asks when is the bug farthest away from the origin, we'd say 4. But where is it?
7 meters.
It's 7 meters to the right. And now, what is the total distance that the bug travels?
9.
It's 9 units, very good. So to find the total distance the bug travels, it would be the absolute value from 0 to 4 of b of t dt plus the absolute value from 4 to 6 of b of t dt. So that would be 7 plus 2, which is 9. Now, what you do not say here is you do not say it's the absolute value from 0 to 6, because that would just be taking the total area, and if you'd gotten a negative value there, you would flip it and say it's positive. Whenever you're trying to do a total distance, you have to break it up into integrals in which you change directions. Every time you change directions, you need a new integral. And it would have also been okay to have said 4 to 6 of the absolute value of b of t. That would have worked in this case as well. If you did the absolute value of b of t, you could flip it around. Another thing you could have done is you could have also said 0 to 6 of the absolute value of b of t dt. That would also give you the correct answer. Because once you say the absolute value of the function, now you're saying every function value has to be positive, so you'd have to flip that up right there. So you could say this and then say that that was 9, or you could break it up into the separate integrals there. That would give you the correct answer. And you could even, I did say this earlier, I just didn't write it down. Absolute value of b of t dt. You could have said this plus that if you wanted to as well. Any question about that? All right. So, looking at question number 100. Question number 100 on that page. This time they don't give us a graph of the function, they just give us the function itself. which is the velocity function, right? And what do they tell us? V of t is equal to what?
T squared minus T minus 12.
And we're concerned about the area from what to what?
1 to 5.
1 to 5. All right, now, what we need to see here is we can't just automatically say that we're looking at this position function as just being the antiderivative of v of t. If we want to know the total distance, for the total displacement, that's fine. So for total displacement is going to be 1 to 5 of t squared minus t minus 12 dt, which would be t cubed over 3 minus t squared over 2 minus 12t from 1 to 5. So that's 5 cubed, which is 125 over 3 minus 25 over 2 minus 60, right? And then it's minus 1/3 minus 1/2 minus 12. Are we still okay? Okay, so 125 over 3 minus 1 over 3 is 124 over 3. Negative 25 halves plus 1/2 would be negative 24 halves. And then negative 60 plus 12 is negative 48. Have I done that arithmetic correct? Okay, 124 over 3. That is simplified. Minus 12 minus 48. So, let's get a common denominator here. We got 124 over 3 minus 36 over 3 minus 144 over 3. So we end up getting 124 minus 36 minus 144. Can someone do that in their calculator real quick?
Maybe 56 over 3.
Negative 56 over 3, thank you. Now, but because this is velocity, it says the velocity function is in feet per second of the particle moving along a straight line. So the displacement would be 56 units to the left. That would be your displacement there. Now, to find the total distance traveled, we need to see where this intersects the x-axis. Because for total distance traveled, we need to do the absolute value part with it. So, where is t squared minus t minus 12 equal to 0? Well, that factors into t minus 4 times t plus 3, right? So we get at t equals 4 and at t equals negative 3. Well, t equals negative 3 we don't care about because that's not in that range from 1 to 5. But 4 is. So, from 1 to 4, we need the absolute value of v of t. Because from 1 to 4, our graph would be below the x-axis. So we got to calculate that and then add it to 4 to 5 of v of t dt. Well, let's anti-differentiate here. 1 to 4 of t squared minus t minus 12. That's again t cubed over 3 minus t squared over 2 minus 12t from 1 to 4 this time instead of from 1 to 5. And we get, all right, that's going to be 4 cubed, which is 64, so we get 64 thirds minus 16 over 2, which we'll go ahead and call that 8, and then minus 48, and then minus 1/3 minus 1/2 minus 12. So 64 thirds minus 1/3 is 63 thirds, which is 21. All right, then I've got -8 plus 1/2, so that's -16 halves, plus 1/2, -15 halves. And then -48 plus 12 is -36. So 21 minus 36 is -15. That's -30 halves minus 15 halves, which would be -45 halves. Y'all don't let me do any of this arithmetic incorrectly. All right, and 45 halves, I want the absolute value of that, so it's going to be 45 halves. All right, now I go to plus, and now I'm going to do the integral from 4 to 5. So that's going to be t cubed over 3 minus t squared over 2 minus 12t from 1 to 4.
Teachers and students, please pardon this interruption. At this time, all seniors need to report to the auditorium. Go ahead and bring your stuff with you. We will dismiss seniors 2-second block following the conclusion of the assembly. But at this time, all seniors need to make their way to the auditorium for the senior assembly. Thank you.
All right, so for homework here, I need you to do question 75 and then 99, 101, and 103. So from that packet 4.4, do questions 75, 99, 101, and 103.